Hello students, in this section we study a special type of relation called function. Now what is a function? Now a relation f from a set A to a set B is said to be a function if every element of set A has one and only one image in set B. That means every element of a domain should have a unique image. Now here I have taken some example. In first one, relation R1 is 2, 1, 3, 1 and 4, 2. Now if you see here, the every element of the domain, that is 2, 3 and 4, has a unique image. Now no element of the domain has more than one images. So it is a function. In relation R2 also, now 1, 2, 3 and 4 has a unique image, that is 2, 3, 4 and 5 respectively. So it is a function. In relation R3, element 2 corresponds to two images, that is 2 and 4. Here element 2 has two images, 2 and 4. So we can say that it is not a function as 2 has two more than one image, or 2 doesn't have a unique image. Now come to exercise 2.3. In question number first, which of the following relations are functions? Give reason if it is a function, determine its domain and range. Now in first relation, now every element of a domain has a unique image. So we can say that the first one is a relation. Now its domain are 2, elements of its domain are 2, 5, 8, 11, 14 and 17 and range is 1. Now in second question, second part, now here also second part we can say that this is a relation as this is a function as every element of the domain has a unique range. Now in third part, element 1 has two images 3 and 5, so it is not a function. In second question, we have to find the domain and range of the following real functions. Now first one is fx equal to minus mod x, and second one is fx equal to under root 9 minus x square. In first part, fx was equal to minus mod x, as this fx is defined for all real numbers. So we can say that x belongs to a real number. Now if x belongs to a real number, then mod x will be greater than equal to 0, because modulus of a real number will be always greater than equal to 0. Now if mod x is greater than equal to 0, then minus mod x will be less than equal to 0, and that means that fx is less than equal to 0. So we can say that the domain of a function is x. That means the domain of the function is real number, and range of the function is the value of fx, and that is less than equal to 0, from minus infinity to 0, where 0 is included in this. Now in second part, fx was given to us as under root 9 minus x square. As we know, under root 9 minus x square is defined for all real numbers. So value of under root 9 minus x square will be greater than equal to 0, as root of a real number cannot be negative. That means 9 minus x square will be greater than equal to 0. Now this will give us x square less than equal to 9, or we can say that x is greater than equal to minus 3 and less than equal to 3. Now here we can solve this as 9 minus x square greater than 0, that on subtracting 9 from both sides we can say minus x square is greater than equal to minus 9. On multiplying by minus 1 we can say x square is less than equal to 9. Now if we take x square equal to 9, then we will get x equal to plus minus 3. For negative sign, we will change the sign of inequality, and for positive sign, the sign of inequality will remain the same. That means x will be less than equal to 3 and greater than equal to minus 3. Or we can say the value of x will be from minus 3 to 3. And here x is the domain. Now again, fx was equal to under root 9 minus x square. As under root 9 minus x square will be greater than equal to 0, so we can say that fx will be greater than equal to 0. Now on taking fx as y will be equal to under root 9 minus x square, and this will give us y square equal to 9 minus x square, or we can say that x equal to under root 9 minus y square. Now this will give us 9 minus y square as greater than equal to 0, as under root 9 minus y square will be greater than equal to 0. Now this will give us y is greater than equal to minus 3 and less than equal to 3. Now from first and second, as y was the value of fx, from first and second we can say that in first fx is greater than 0. That means fx is from 0 to infinity. Now in second part, fx lies from minus 3 to 3. That means fx is from minus 3 to 3. Now if you observe here, the common part of equation first and second, or inequality first and second, is from 0 to 3. That means the value of fx is from 0 to 3, or we can say fx is from 0 to 3. So we can say that the domain of the function, that is value of x, lies from minus 3 to 3, and the range of the function, that is value of fx, is from 0 to 3. In third part, or third question, a function f is defined by fx equal to 2x minus 5. We have to write the values of f0, f7 and f minus 3. I am doing third part of it. Now here we have to find f minus 3. Now this is a simple question. Now if we, in place of x, now fx was given to us 2x minus 5, and here in place of x there is minus 3. So we will replace x with minus 3. That means f minus 3 will be 2 into minus 3 minus 5, and that will be equal to minus 11. In question number 4, the function t, which maps temperature in degrees Celsius into temperature in degree Fahrenheit, is given by Tc equal to 9c upon 5 plus 32. Now here we have to find T0, T28, T minus 10. These three parts can be obtained as we have done question number 3. Now in fourth part, the value, we have to find the value of C when Tc is 212. Now when Tc is equal to 212, we have to find the value of C. So in place of Tc, we will take 212, and that will be equal to 9c upon 5 plus 32. And on solving this, we can get the value of C, and that is equal to 100. In fifth question, we have to find the range of each of the following function. Now first one is fx equal to 2 minus 3x, where x belongs to real number and x is greater than 0. Now here, as we see x is greater than 0, so from this, using this, we will find out the value of 2 minus 3x. Now if x is greater than 0, then 3x will be greater than 0. Now here it is minus 3x, so on multiplying both sides by minus 1, minus 3x will be less than 0. Now whenever we multiply the inequality by a negative sign or divided by a negative sign, then the sign of inequality changes. Now here, on adding 2 to both sides, as we need 2 minus 3x, on adding 2 to both sides, 2 minus 3x will be less than equal to 2 plus 0. And that means 2 minus 3x will be less than 2. And that is the value of fx. That means fx will be less than 0. So we can say that the range of the function is from minus infinity to 0, or between minus infinity and 0. Now in second part, fx is given to us as x square plus 2, and here x is a real number. Now if x is a real number, or we can say if x belongs to real number, then x square will be greater than equal to 0, as the square of real number is always greater than equal to 0. Now on adding 2 to both sides, x square plus 2 will be greater than equal to 0 plus 2, and that will give us x square plus 2 greater than equal to 2. And here fx, x square plus 2 is equal to fx. So fx will be is greater than equal to 0. That means the range of the function will be from 2 to infinity. In third part, fx is equal to x. A function is given to us where fx is equal to x, and x is a real number. Here x belongs to real number, so we can say fx will also belong to a real number, or we can say fx, that means range of a function will be a real number. Now come to miscellaneous exercise on chapter 2. Now two relations are given to us, fx and gx. We have to prove that fx is a function and gx is not a function. Function fx is given to us as x square if x is greater than equal to 0 and less than equal to 3, and 3x if x is greater than equal to 3 and less than equal to 10. Now for x is greater than equal to 0 and less than equal to 3, fx equal to x square, and for x is greater than equal to 3 and less than equal to 10, fx equal to 3x. Now here we can obtain the value of f3 from both the parts of the relation. Now at x equal to 3, fx equal to 3 square. From the first part, we can say that fx equal to 3, f3 will be equal to square of 3, and that will be equal to 9. Or from the second part, we can say f3 will be equal to 3 into 3, and that is also equal to 9. So at x equal to 3, fx is equal to 9 in both the cases. Therefore, for x greater than equal to 0 to x less than equal to 10, the image of fx are unique. That means the given relation is a function. Now, second relation is gx equal to x square for x is greater than equal to 0 and less than equal to 2, and 3x for x is greater than equal to 2 and less than equal to 10. Here 2 is common in both the parts. So at x equal to 2, fg2 will be equal to square of 2, that equal to 4. And in second part, we can say that f2 will be equal to 3 into 2, and that equal to 6. Here element 2 of the domain of relation G corresponds to two images 4 and 6. Hence the relation is not a function, as 2 has element 2 of the domain has two images 4 and 6. Now in second question, a function fx is equal to x square is given to us. We have to find the value of f1.1 minus f1 upon 1.1 minus 1. Now f1.1 will be equal to 1.1 square, f1 will be 1 square upon 1.1 minus 1. Now, on solving this, we will get the value of f1.1 minus f1 upon 1.1 minus 1 as 2.1. In third question, we have to find the domain of the function fx equal to x square plus 2x plus 1 upon x square minus 8x minus 12. Here, function fx is given to us. Now, x square plus 2x plus 1 can be written as x plus 1 whole square, and x square minus 8x plus 12 can be factorized as x minus 2 into x minus 6. Now, it can be seen from the function that function f is defined for all real numbers except x equal to 2 and x equal to 6, as x equal to 2 will give us the value of function as denominator of the function as 0, and anything upon 0 is not defined. Also, x equal to 6 will also give us the denominator as 0, and so at 2 and 6 the function will be not defined. Thus, we can say that the domain of f is real number, can be any real number excluding 2 and 6, or we can write it as real number excluding 2 and 6. In question number 4, we have to find out the domain and range of the real function fx equal to root x minus 1. Now, the given real function fx equal to root x minus 1, here root x minus 1 is defined for x minus 1 is greater than equal to 0, or we can say root x minus 1 will be greater than equal to 0, as root of a real number cannot be negative, and from that we can say that x minus 1 will be greater than equal to 0. Now, if x minus 1 is greater than equal to 0, then x will be greater than equal to 1. Therefore, that fx equal to under root x minus 1 is defined for x greater than equal to 1. Therefore, the domain of f is the set of all real numbers greater than equal to 1. Or we can say that domain of f is from 1 to infinity. As now, here x is greater than equal to 1, so we can say that x minus 1 will be greater than equal to 0, or root x minus 1 will be greater than equal to 0. That means the value of fx is greater than equal to 0, or range of f is greater than equal to 0, or from 0 to infinity. Now, in question number 5, again we have to find the domain and range of the real function fx equal to mod x minus 1. Now, it is clear that mod x minus 1 is defined for all real numbers. Now, in place of x, we can take any real number to get a real value of fx. Therefore, domain of f will be a real number. Now, also, if x belongs to real number, then mod of x minus 1 will be greater than equal to 0, as modulus of a real number is always greater than equal to 0. Hence, the range of the function f will be a set of all non-negative real numbers, or you can say that range of f is set of all positive real numbers, or you can say from 0 to infinity. In question number 6, function f defined by x comma x square upon 1 plus x square, where x belongs to a real number, is given to us. We have to determine the range of f. Now range domain of the f is given by x and range will be x square upon 1 plus x square. Now for x equal to 0, x square plus 1 upon x square will be equal to 0. For plus minus 0.5, x square plus 1 upon x square will be 1 by 5. For plus minus 1 by 2, for x equal to plus minus 1 by 2, x square plus 1 upon x square will be equal to 1 by 2. Sorry, for x equal to plus minus 1, x square plus 1 upon x square will be equal to 1 by 2. Similarly, for x equal to plus minus 1.5, x square plus 1 upon x square will be 9 by 13. And similarly, we can find the value of x square plus 1 upon x square for other real numbers. Now, here the range of f, that is the set of the second element, are greater than or equal to 0 and less than 1. Thus we can say that range of f is greater than equal to 0 and less than 1, or from 0 to less than 1. Now this can be proved in another way also. Now here x belongs to real number, so x square will be greater than equal to 0 and 1 plus x square will be greater than equal to 1. Now from these two we can say that x square plus 1 upon x square, that was our range or image, will be greater than equal to 0 upon 1 or greater than equal to 0. Now as we see here that 1 plus x square is greater than x square, so x square plus 1 plus x square will be always less than 1. Thus from these two equations, this first and this one is second, we can say that value of x square plus 1 upon x square will always be greater than equal to 0 and less than 1, or range will be from 0 to less than 1. Now in question number 7, f and g are two real functions is defined by fx equal to x plus 1 and gx equal to 2x minus 3. We have to find the value of f plus g, f minus g and f by g. Now the sum, the difference and multiplication and division of the functions is similar to the sum, difference, division and multiplication of the polynomials. Now here we have to find f plus g. So f plus gx will be fx plus gx. Fx was x plus 1 and gx was 2x minus 3, and that will give us the value as 3x minus 2. Similarly, we can find f minus gx. Now f by gx will be fx by gx. Now that will be x plus 1 upon 2x minus 3. Now as we know that a function is defined only if this 2x minus 3 is not equal to 0, or we can say 2x is not equal to 0, or from this we can say that x is not equal to 3 by 2. Thus f by gx will be equal to x plus 1 upon 2x minus 3, where x is not equal to 3 by 2. Now we should always keep in mind that the denominator of the function cannot be equal to 0. In question number 8, let f equal to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a function from z to z or integer to integer defined by fx equal to ax plus b for some integer ab. We have to determine the value of a and b. Now here 1, 1 belongs to f. That means f value of f1 is equal to 1. Now f1 will be equal to a into 1 plus b, and that was equal to 1. That means a plus b equal to 1. Now I am taking this one. Now 0 minus 1 also belongs to f. That means f0 is equal to minus 1. Now f0 will be equal to a into 0 plus b, and that equal to minus 1. This will give us b equal to minus 1. Now on putting the value of b in equation first, a plus minus 1 will be equal to 1, and that will give us the value of a as 2. Thus a is equal to 2 and b equal to minus 1. In question 9th, a relation R from n to n, natural number to natural number, defined by R equal to AB, where AB belongs to n and A equal to B square. Now, are the following are true? We have to check whether the following statements given to us are true or not. Now, first one is A belongs to R for all A belongs to natural number. Now, this can be proved by giving the example. Now, first one, for 2 belongs to natural number, we have to check whether 2 belongs to R or not. Now, as 2 is not equal to square of 2, which is equal to 4, therefore we can say that AA does belongs to R for all A belongs to natural number is not true. Now the second statement is if AB belongs to R implies that BA belongs to R. Now it can be seen that 9, 3 belongs to R for 9 and 3 belongs to natural number and 9 equal to square of 3. But 3 is not a square of 9, which is equal to 81. Therefore 3, 9 doesn't belong to R. Therefore the statement AB belongs to R implies that BA belongs to R is not true. That means if 9, 3 belongs to R, then 3, 9 doesn't belong to R. Now third one is AB belongs to R and BC belongs to R implies that AC belongs to R. Now here we have to keep in mind that the second element in first case and the first element in second case should be same. Now it can be seen that 16, 4 belongs to R and 4, 2 belongs to R. For 2, 4 and 16 belongs to natural number, as 16 is equal to square of 4 and 4 is square of 2. Now 16 is not equal to 2 square, which is equal to 4. Therefore 16, 2 doesn't belong to R. That means for 16, 4 and 4, 2 belongs to R, 16, 2 doesn't belong to R, as it does not satisfy the relation which is A should be equal to B square. That means the statement AB belongs to R and BC belongs to R implies that AC belongs to R is not true. And question number 11, let F be a subset of Z cross Z, that is integer to integer, defined by F AB, comma, A plus B, where AB belongs to integer. If F a function, is F a function from Z to Z? Justify your answer. Now we have to check whether this F equal to AB, A plus B, where such that AB belongs to Z is a function or not. We know that the relation from a set A to B is said to be function if every element of set A has unique image in set B. Since 2, 6 minus 2, minus 6 are integers or belong to integer. Now, if you take 2 6 to 2 into 6 and 2 plus 6 belongs to f, and in case of minus 2, if we take minus 2 and minus 6, then minus 2 into minus 6 and minus 2 plus minus 6 belongs to f. Now here 12, 8 and 12 minus 8 belongs to f. Here 12 corresponds to two different images, 8 and minus 8. Thus, the relation f is not a function, as the image of 12 has two images, 8 and minus 8. In question number 12, set A is given to us and let f such that A tends to n be defined by fn equal to the highest prime factor of n. Find the range of f. Now we have to find the range of the function f for f such that A tends to n, where fn is the highest prime factor of n. Now here highest prime factor of 9 is 3. Similarly, highest prime factor of 10 is 5. Of 11 is 11. Highest prime factor of 12 is 3. And highest prime factor of 13 is 13. So, f will be 9, 3, 10, 5, 11, 11, 12, 3 and 13, 13. Now we have to find the range of f. The range of f will be the second element of the function, that is 3, 5, 11, 3, 13. Thank you.